All right, and then in this final video, we're going to be looking at a situation where we're dealing with having the square root of something squared. Okay, so that can cause a little bit of a problem. So here at the top, I just want you to think about that a little bit. The square root of something squared, okay, isn't always equal to x. Okay, in reality, it's equal to x only when the x was a positive number. For instance, if x were 3, so if x equaled 3, then equaled 3, then you would have the square root of 3 squared would equal the square root of 9, and the principal square root of 9 would have been 3. So an x went in, and you really did get an x coming out. Here's the thing that people sometimes forget about. The square root of x squared might equal the opposite of x. Because, for instance, if x itself were -3, and we were to plug that in here, a -3 quantity squared really would equal the square root of 9, principal square root of 9, which is 3, and that's not x. That's the opposite of x. Okay? So that is sometimes what people forget when you're doing these limits as x approaches an infinity, especially when x is approaching a negative infinity. We're going to have that issue come up in a moment. Okay? So I'd like to, this can get extremely complicated. I don't want to show you the official way. I just want you focusing on how it's the leading term. We can still focus on the leading term top and bottom. It's going to seem weird, but that little +2 and that little +3 have minimal effect when x is approaching an infinity. All right, so basically we're going to be able to ignore it. And I'd like to just think about it with actually substituting in an infinity, which feels like a weird thing to do, but it might be just a good intuitive way to figure these out, or it is a good intuitive way to figure these out. So see that little 2 and that little 3 underneath there, we can just ignore them. So basically we have a 5 infinity squared, and then down here square root of an infinity squared. Okay, and that infinity is a positive infinity being squared in that denominator. So this winds up being a 5 infinity squared over, the denominator would just be a positive infinity. And then you could kind of treat it like the magnitude on top was bigger, but down here we had like an infinity to the first power. We could knock out one of those infinities, and we could wind up with a 5 infinity, and positive 5 times positive infinity would be infinity. So our answer would be infinity. Now, you can take the leading terms, top and bottom. Don't forget down there, it's not an x squared, but really a square root of x squared, and really ignore the little stuff. You could simplify at that point if you wanted, but you need to be careful. I think it helps to wait until you've plugged in the infinity, because that square root of x squared isn't always going to equal x. It will here, because we're approaching a positive infinity. So what's going in for x are positives, is why that's x. And then you'd get a 5x and can plug in your infinity. But I feel like it's better to get the infinity in there first, so you're less likely to mess this up when you're doing the square root of x squared. Okay? All right, now you could just start with this though, ignoring the 2 and the 3 right off the bat. All right, so let's try another one using an intuitive method. All right, so here what we've got is x over the square root of x squared. Okay, so basically we're looking at the limit, and on top we have an x. We're plugging in a negative infinity there. I'm going to be focused right here. We have a negative infinity, and then down here the leading term would have been the square root of x squared. Put a negative infinity in there, and let's think about this. Okay. So do you see on top, that looks messy. Let me make that look better. Square root of negative infinity squared. All right, so I'm ignoring the 1 because it has little effect on things. I think it works well to go ahead and put the infinities in there so you can think about it. So in the numerator, we have a negative infinity. In the denominator, that negative infinity is being multiplied by itself, which is going to be positive infinity, the same as positive infinity squared. And then if you square root a positive infinity squared, you're going to get an infinity. Okay. And then the magnitude is the same top and bottom, and so you're just going to look at the leading coefficients there, and your limit is going to turn out to be a -1. So like this one would have no horizontal asymptote. This one would have a horizontal asymptote of y equal -1. Okay? All right, so basically that square root of x squared on the bottom really is also degree 1. That square root of x squared on the bottom would simplify to be either x or -x to have the same degree as what we have in the numerator. Okay. All right, now let's take a look at question number 9. All right, on that one we can ignore the -3 and just focus here. We can imagine the bigger and bigger numbers going in for x. Okay, top and bottom. All right, let's think about how in the denominator we're doing the square root of 9 infinity squared. So that denominator would be square root of 9. Since it's times, I can do the square root of 9 and get 3. If I do the square root of a positive infinity squared, it's going to be an infinity. Okay, and then those infinities I can get rid of, and I wind up with 7/3. And then y equals 7/3 would be a horizontal asymptote. The limit is 7/3, and that also means I have a horizontal asymptote. That would be y equals 7/3. Okay. Now, I want you to compare that to what happens when I plug a negative infinity. When we let x go towards negative infinity, then that numerator, I'm going to put in a negative infinity. I'm still able to just focus there because the -3 is just subtracting of 3. That's minimal effect. When I plug in a negative infinity, I'm turning around and squaring it. And so I wind up having -7 infinity on the top. But down here, this negative infinity squared is really the same. Infinity, negative infinity times negative infinity is positive infinity squared. So I have that turns out to be 9 times positive infinity squared that I'm taking the square root of. So this time, I wind up having a -7 infinity on top, and when I do the square root of 9, I get 3, and the square root of a positive infinity squared would be infinity, okay? And so I wind up with a -7/3 as my limit. So the limit here would have equaled 7/3. The limit here would have equaled a -7/3. Now, it's not as easy as this is negative, and so that makes it negative. It really depends on the other parts of the problem and how things really work out. Okay. All right, let me go ahead and do B the official way, and let you know, if you were doing it officially, what you might see if you're looking at CalcChat or something like that. So I'm looking at B, but I'm going to do it officially this time. All right, if you were doing it officially, people usually get lost. That's why I'm recommending you use a more informal approach, focusing on the leading terms, top and bottom, and going ahead and plugging in the infinity. If you're doing the approach, the official approach, okay, this is how you would do it. So what you would divide by is the square root of x squared, top and bottom. So the 2 here, but square root of it. So you would take the original limit would be equal to this one, 7x over the square root of x squared divided by, and here it would be the square root of 9x squared minus 3 divided by the square root of x squared. So then what you would do in the denominator is you could distribute that, since they're both square roots, you could put it back together underneath one radical down in the denominator, and you'd have 9x squared over x squared minus 3 over x squared. And in the numerator, you'd have to do a little simplifying, and here's where people mess up. The square root of x squared here, the square root of x squared would equal the opposite of x, since x is approaching a negative infinity. Okay? Because you're plugging in more and more negative numbers there. So if you plug in a negative number and square it and then take the square root, you don't get negative 3 out, you get positive 3. You get the opposite out. And so folks have trouble with that. So when you're simplifying this, this would really be a 7x over the opposite of x, since we're plugging in negative numbers. Okay? That's the danger of trying to do it the official way, is a lot of times people don't understand that, and so they don't wind up getting on top the negative 7 that they would need. Now in the denominator, we'd have the square root of 9, and then if I'm plugging in an infinity of any kind, if I'm plugging an infinity of any kind in here, let me keep the limit in there like I'm supposed to. Then this would go to 0, and I'd have negative 7 over the square root of 9, which is negative 7 over 3. I just feel, and I've seen it happen, that people are going to miss that negative right there if they try to use the official approach. Okay? So what I recommend that you do is use a more informal approach that involves using direct substitution and focusing on the leading terms on top and bottom. So for this one, you would simply think 7 times negative infinity over the square root of 9 times negative infinity quantity squared. You'd think about that being negative 7 infinity, and negative infinity times itself would be positive infinity squared. So then when you wind up thinking about how that would simplify, then in the denominator you'd have a 3 infinity, same magnitude top and bottom, and you wind up getting negative 7/3 like you needed to. Okay? All right, I have two more that I want to do involving e. All right, so again, on these, it just works out really well to go ahead and think about plugging in a negative infinity. Now, you're really not plugging in a fixed number. You're really imagining your x value getting more and more negative. Okay, so think about that. So this would be negative 5 over 1 plus 3e to the positive infinity. So we know that e to the positive infinity gets bigger and bigger, so it goes to infinity. You multiply by 3, that's infinity. You add 1, that's infinity. So really that whole denominator is going towards infinity. Okay? That whole denominator is going towards infinity. So if you have negative 5 over infinity, any fixed number over an infinity of any kind, then that's approaching 0. So the limit of this would be 0. All right, now on this one, same expression, but I'm plugging in a positive infinity. So here I have 1 plus 3e, and I'm plugging a positive infinity in for the x, but there was already a negative there. Okay? So I like to think about it using my exponents. So that e to the negative infinity is the same as I would have 3 over e to the positive infinity. Okay? And e to the infinity is going to get bigger and bigger and bigger. So a fixed number over that, that's going to go to 0. So then you wind up having negative 5 over 1 plus 0. And that would wind up being negative 5. And so your answer to that would be negative 5. So this one turned out to be equal to 0. This one turned out to be equal to a negative 5.